Next question, it says a model for an Olympic standard 100-meter sprinter was developed by mathematicians. The speed of the sprinter may be calculated using the function. So this function is written in speed, where t is time in seconds from the starting signal. So t is in seconds. Okay, find the maximum speed. Now, any mention of max or min in a calculus question. Now, I know the test was on logs and indices, but there was this exponential within there. So anyway, this is ultimately a calculus question. So any mention of max, you differentiate once and you let it equals to zero. You let it equal zero. So before I go to differentiate it, I'm just going to tidy it up a little bit because of the brackets. So I'm just going to multiply out the brackets like I would do in algebra. So 11.7 minus 11.7 e to the negative 0.8 t. Then I'm going to do the same here, plus, so I'm just multiplying out my bracket, 0.03 minus 0.03 e to the 0.3 t. Now, in a moment, I'm going to differentiate this, but I'm already kind of predicting a bit of a problem here. So let's recap on something. If I have e to the x and I differentiate that, it is still e to the x. But in this particular question, for example, I don't just have e to the x, I have e to the negative 0.8 t. So if I was to let u equals to the complex part, then I can figure out e to the u. Now, e to the u, when I differentiate it, just becomes e to the u. But we also would have to differentiate the u part. So if I do du dt, I end up getting negative 0.8. So long story short, when I differentiate something that's more complicated than just an x or a t, what happens is this part is going to go in the front, and then this part remains the same. So there's just that extra kind of a step. So the differentiated version of that is this. So yes, it stays the same, but you do have to do the derivative of anything that's in front of the x or the t. So in other words, if it's more complicated than just e to the x. So you can do that on the side of the page first if you want, or maybe it's something that I think at the time when we were learning this, some of you were just learned that if it was more complicated than just an x or a t, for example, that you put down that power in the front. So let's go ahead now and differentiate. So I'm going to now differentiate w of t, so w prime of t. Now, any number on its own goes, so 11.7 is gone. Now, when I go to differentiate this, the negative 11.7 will still be there because any number that's multiplying is still going to be there. Then the actual e itself, so this part, as I've just explained, is going to turn into this. So that's what comes next. So I'll just put a bracket here, negative 0.8 e to the negative 0.8 t. The next one is just a number, so that's gone. So any number on its own is gone. Now the next one, again, the 0.03 stays because it is multiplying our e, so that's still there. But we need to remember that this bit, just like the other yellow bit, has to be done as well. So if we look and compare it to the other one, what's going to go here? So what we're going to do really is we're going to have whatever number is in the front, we're going to have to multiply this by 0.3, and then the actual e part itself is going to stay the same. So we're going to have e 0.3t. So I hope that makes sense. So now we just have to multiply out. So I have the negative 11.7 times by the negative 0.8. So that gives me 9.36 E, 9.36 e to the power of negative 0.8 t. Now, with the next one, I have 0.03 multiplied by 0.3. So that becomes negative 0.009 e to the power of 0.3 t. So that's our derivative done. We have to let that equal to 0 now. So that's what I'm going to do. So we're going to let this equals to 0. Now, because this is a negative, I think I'll just put this under, if that's okay. So that gets rid of the negative in the power. This guy, I'll just pop him over 1, because if I have a fraction, it's probably better to write everything as a fraction. And I'm going to let it equals to 1. Why? Because anytime we're maximizing, we differentiate once and we let it equal to 0. So our common denominator should be e to the power of 0.8 t. The first guy has it already, so no change to the bottom, no change to the top. The other guy, well, he doesn't have that in the denominator, so he's going to have to get that part. So I'm going to just put that in there, e to the 0.8 t. Now remember, this is equal to 0 over 1. So now if I cross multiply 9.36 minus 0.009 e to the 0.3 t, and e 0.8 t equals to 0. Okay, so we're getting quite close. Now, if we have two things with powers, remember the rule is we can, if they're being multiplied, we add the indices. So that's negative 0.009 e to the power of. Now, let's work this out. So we have 0.3 plus 0.8. So that becomes 1.1. Okay, so we have 9.36, and then this is 0.009 e to the power of 1.1 t, and this is all equal to 0. So now I guess we're going to move it to, we're going to solve it. So I'm going to move it to the other side. So I'm going to move over to minus 9.36. Now I want to ultimately aim to get that t out. So I'm going to move him over, and his job is going to be dividing. Now, when I divide that in, let's see what that is. So that's going to be, so I'm hitting my fraction button, negative 9.36 divided by negative 0.009. So that's 1040. So e to the power of 1.1 t is 1040. Now, again, there's always a few ways to approach these questions, but if we have the natural log of e, that's 1. So if we take the natural log of both sides, so we're introducing logs as a way of solving, basically. So if I get the natural log of both sides, first of all, I can move down my power. So I can move down my 1.1 t natural log of e is equal to the natural log of 1040. Now, natural log of e is 1. Remember, the natural log is really log to the base e. So if you've matching base and number, it's 1. So all of that is just going to become 1. So that's gone essentially. Now we have the natural log of 1040 on the other side. So finally, to get t, I'm going to do the natural log of 1040 over 1.1. So the natural log of 1040 over 1.1. No, sorry, just have to close my bracket here. So that gives me t is equal to 6.31543, etc. Now, we're nearly there, but the question is not find the maximum time. The question is find the maximum speed. So what I have to do now is rewrite the original sentence, which talks about speed, and then fill in my t. So speed So I'm just rewriting that original sentence. So speed, we are told at the beginning of the question, is this. So 0.3t. So what I'm going to do now to get my final answer is everywhere there is a t, we fill this in. So 11.7, 1 minus e to the power of minus 0.8, and then I'm multiplying that by 6.31543. So just leave in a few decimal places so that we don't round too soon. So now your calculator is going to do this for you. So I know it looks a little bit messy, but it's no big deal really. Your calculator is going to do it all. So now we'd pop it into our calculator, and finally to 2 decimal places, we get 11.46, and it's going to be meters per second. And that's our answer.